Assalamu alaikum warahmatullahi wabarakatuh. So in this video we will look at the parallel operation of the synchronous generators. Means if we have more than one generator to supply the load, because in physical power systems we usually have more than one synchronous generators that are used to produce the electricity. So several generators can supply bigger load than one machine by itself. So having many generators increases the reliability of power system, obviously, since the failure of any one of them does not cause a total power loss to the load. So having many generators operating in parallel allows one or more of them to be removed for shutdown and preventive maintenance. So we can easily, just like here, if we have these two generators, we can even remove a generator, one of the generator, if there is not a demand for the load, or we need some certain maintenance of any generator. So we can shut down any one of the generator and we can again plug it back to the power system. So if you have only one generator and that is operating at near full load, then it will be relatively inefficient. With several smaller machines in the parallel, it is possible to operate only a fraction of them. The ones that do operate are operating near full load and thus more efficiently. Obviously, the full load means that in 24 hours there will be a few hours then that we can there is a demand of the power, but not all the time that the power demand remains the same. So at the time when the power demand is very low, at that point obviously we can shut down few generators to reduce the cost. So the conditions for parallel synchronous generators includes that the RMS line voltages of the two generators must be equal, and the second one is the two generators must have the same phase sequence, and the third one is the phase angles of the two A phases must be equal, and the frequency of a new generator called the oncoming generator must be slightly higher than the frequency of the running system. So let's look at the different methods to synchronize the generator. So in this figure we can see that this is known as the 3-lamp method, and if we want to connect the generator with if we have this one already working generator and this is the oncoming generator, so we will put the 3 bulbs such that they are connected, one phase is connected to the one generator, and the second leg of the bulb is connected to the second generator, one of the phase of the second generator. Similarly, we can have these three bulbs added to the system to parallel this generator. So for the oncoming generator, we have to check all these 4 conditions, that the RMS line voltages of the two generators must be equal. So voltmeter simply can be used, and the field current can be adjusted such that both the generators have the same RMS values. And secondly, that we have the phase sequence of the incoming generator must be compared to the phase sequence of the running system. As we can see, if the phase sequence is different, just like here we can see that this is VA, VB and VC, and if we have this VA, VC and VB, so it means that this is the ABC sequence, ABC, and this is the ACB sequence. So although this VA phase A is are in phase, but the VB and VC are not in phase, so if phase A will be okay, but in the phases B and C, a huge currents will produce that can even destroy both of the generators. So that's very simple to change the sequence. Just swap any of the two of the sequences to check this. But we have certain methods to check that if the phase sequence is correct. So this method here we can see is known as the 3 light bulb method. So in this approach, 3 light bulbs are stretched across the open terminals of the switch connecting the generator to the system. So as the phase changes between the two systems, the light bulbs first get bright, large phase difference, and then get dim that's the small phase difference. If all three bulbs get bright and dark together, then the system have the same phase sequence. So if the bulbs brighten in succession, then the systems have the opposite phase sequence, and one of the sequences must be reversed. So we can reverse this. There is another method to check this. If we can connect a small induction motor, small induction motors, and if we want to check, we can have the we can use it to check the rotation of the motor. So if it is rotating in the same direction, so obviously that would be in the same sequence. The next thing is the next thing is the phase angles of the two phases must be equal. So if the for the phase angles, if the voltages of the phase voltage of phase A of generator 1 and the voltage of phase A of generator 2, if they are identical, if their magnitudes all identical all the times, then their angles are same. And the last one is that we must keep the frequency of the incoming generator slightly higher than the generator which is already connected to the system. So this is actually the frequency adjustment is done by first watching the frequency meter until the frequencies are close, and then by observing changes in the phase between the systems. The oncoming generator is adjusted to a slightly higher frequency so that when it is connected, it will come on the line supplying power as a generator instead of consuming it as a motor. So obviously if the frequency is lower, so it will act as a load to the first generator. So we have to put the second generator at a frequency slightly higher than the generator, because when the load will be connected to this generator, it will obviously adjusted automatically to the frequency of the generator which we have. So and there is another device called the Synchronous Scope, that is a meter that measures the difference in phase angle between the phases phases of the two systems. The Synchronous Scope actually is not here. So it is actually a small machine, a small meter, and its frequencies of the two systems are slightly different, so the phase angle on the meter changes slowly. If the oncoming generator or system is faster than the running system, then the phase angle advances and the synchronous scope needle rotates clockwise. If the oncoming machine is slower, the needle rotates counterclockwise, and when the synchronous scope needle is on the vertical position, the voltages are in phase and the switch can be shut to connect the systems. So this is how we can plug in the synchronous generator to the if we have one generator and we want to plug in another synchronous generator to our power system. So I hope you have understood how we can parallel two generators, and the paralleling generators for more than two generators is the same. We have to go over all these checks before paralleling any other generator. Means if we have the third generator that we want to add to this power system so that it can provide the power to the load, so we have to go through all these systems. Although these are not done nowadays manually, all the things are handled by the sophisticated SCADA systems. So they just measure all these things, and they just plug in the generators automatically and removes the generators smoothly from the power system. So still obviously we have to know all these conditions if you are working in the power generation plants. So I hope you have understood the method of this paralleling and the working of the generators, the synchronous generator working in parallel. So if you still have any questions, please feel free to ask. Assalamu alaikum wa rahmatullahi wa barakatuh.